I worked with colleagues that were focused on the OSAP and the skinwalker phenomenon. What I can say is that they are very convinced, and I think I am too, that there are things that probably go bump in the night.
I don't think, again, if I'm correct, and that consciousness is a piece of this, this is definitely going to stay a step ahead. And I came up with a phrase called the precognitive sentient phenomena. And the point there was that we were studying certain things, but there was a, I hate to call it, I don't know how to describe it, a supernumerary that was definitely in charge. And it seemed to know how we would respond to phenomena before the observation took place. It was certainly sentient, it was certainly smarter than us, and phenomenological. And all was one step ahead. Every time we get close and start to study, you say, oh, you like that? Try this. Now you're seeing similar sorts of things in the UFO phenomena as well, as it morphs enough to stay ahead of whatever sensors or data collection systems that we have, and it changes over time.
One experiment that captures the key features of quantum mechanics is the double slit experiment. If you send a beam of electrons at two narrow slits, well, the electrons, rather than behaving like particles and ending up in two clumps behind the slits, they produce an interference pattern, even when you send each electron through one at a time. He postulated that all particles have a wave that accompanies them and guides their motion, and that wave is actually created by tiny oscillations of the particle. Now, every time the droplet lands on the surface, it creates a wave. But this is a special type of wave. It is a standing wave, meaning that it's not traveling out, it's just oscillating up and down. So the droplet makes the wave, and then it interacts with that wave on its next bounce. If the drop lands on one side of the wave, it is pushed forwards. And as long as the bounce of the droplet remains synchronized with the wave, it'll keep landing on the front side of the wave and getting pushed farther forwards. With walking droplets, the pilot wave goes through both slits, interfering with itself, while the droplet only goes through one slit. Now, this pilot wave theory was marginalized when the standard Copenhagen interpretation became widely adopted. The Copenhagen interpretation excludes anything that cannot be directly observed, and it says everything that can be known about a particle is contained in its so-called wave function. And it also meant that the universe was no longer deterministic. Randomness is built into standard quantum mechanics. According to quantum mechanics, the wave function of the electron is a superposition of the electron going through one slit and the other slit simultaneously.
Schrodinger had this idea when he came up with this equation in quantum physics. He said you can write an equation that describes everything with a wave function. This thing we call a quantum wave function. I call them QWIFs for short, and that's what I'm going to say. And you know, I'm saying quantum wave function. Well, a lot of people didn't like this quantum wave function stuff. They said, if this mathematics is true, it can describe everything in the universe, and it's really weird until you actually observe it, and you know if it's in this state or that state. It's both at the same time. And so I have an experiment. Some famous scientist said back in the 1910, 20, 30s, in that time frame, and they still argue about it today. So they said, let's take a cat and shove it in a box, and let's put a little quantum event in there, and when the quantum event goes off, it's a 50-50 chance, like flipping a coin. If it happens, it breaks a vial of poison gas, and it kills the cat. If it doesn't happen, the cat's just fine. But you can use no instruments that can peer through the box to know if the cat's alive or dead. Well, then according to you, Mr. Schrodinger, and according to you, Mr. Niels Bohr, another famous scientist, this equation you have tells us that that cat is both alive and dead at the same time. What malarkey! No, it's not. We've actually proven it experimentally, not with cats, but with atoms and other things. It's absolutely true. The cat is alive and it is dead at the same time. There are physicists that will argue with you and say, no, it's the observation or some other things. Well, those physicists were a little bit misguided through graduate school. We've actually experimentally, within the last year, verified that the Copenhagen interpretation of modern physics, meaning the cat is alive and dead at the same time in the box, is true. It's an experimental, verified fact.
You see it in the world of random chaos as well. I mean, what seems at our level to be random and chaotic, really, in the grand scheme of things, there's a rhythm, there's a pattern to everything. I don't want to get too philosophical because I'm certainly not qualified to lead a philosophical conversation, but there seems to be this ebb and flow in the universe, and you have these distinct patterns and rhythms, if you will, or frequencies that occur. And random chaos is another one of those little aha moments, like fractal universe, where you begin to realize what seems random and disparate at the micro level really is quite orderly, and it's not so random after all. There's symmetry there, even in the chaos and the noise, there is still order. And
once you begin to see that in nature and see that in life and see that in human behavior, things tend to make maybe a little bit more sense. We realize we really are part of something much bigger, much greater.
The leaf, it turns out, is a remarkable piece of technology. Light lands on a leaf in quantum energy packets called photons. Every second it spends in bright sunlight brings a leaf thousands of trillions of photons. And almost every one of the red ones is captured and its energy processed. Let's trace the path of that energy through the plant. The first stop is the antenna, an assembly of hundreds of thousands of chlorophyll molecules. Hit by the photon, an electron within the chlorophyll will become excited and use the extra energy to bounce through the antenna to a bridging area. This is composed of a complicated arrangement of chlorophyll molecules. You can imagine it as an intertwined maze of roped bridges that, if you can find the path through, lead to the all-important reaction center. Once at the reaction center, the electron creates a permanently separated charge that is essentially energy that can be stored. It's the same thing that makes a fully charged battery such a useful source of power. At that point, the energy is safe and properly stored, ready for use by the plant. There's just one catch. The reaction center is a nearly impossible place to reach. Getting through the bridging area is a nightmare, and it has to be done quickly. The maze of wobbly rope bridges will absorb all the photon's energy if it takes too long to find the reaction center. A packet of energy has about 1 nanosecond to get across the bridge. Some might chance upon the right path and make it through in time. Most, though, won't. Our results suggest that the energy of absorbed light resides in 2 places at once. This weird phenomenon is officially known as quantum superposition. It is written into the mathematics of quantum theory, which describes the position of a particle only in terms of probabilities of finding it in various different places. In certain circumstances, the particle can occupy multiple positions at once. And it turns out that to achieve the remarkable efficiency of photosynthesis, algae and their evolutionary descendants, plants, employ quantum superposition so that the energy can simultaneously travel along all possible paths to the reaction center. That way, it always gets there on time. As far as we understand it, when a photon of sunlight hits a leaf, its energy is passed to electrons within the leaf's chlorophyll molecules. Those excited electrons move to the reaction center not by random hops, as was thought, but by exploiting their quantum mechanical ability to take all available paths at the same time.
We're all part of the universe, remember? We're all a part of it. And a lot of scientists, neurologists, and people argue for years, centuries, that the brain works as a neural network. A neural network, wow, it's really a bunch of classical ideas that work together, and the more connections you make, you're going to get Skynet, and it's going to make all the machines come up and kill us all. Well, it turns out we've recently sort of discovered, there's a few scientists that will argue this till they're blue in the face, and I'm one of them, that the brain is not a neural network. It actually is a quantum computer. It works through quantum physics, and it follows the rules of quantum physics. And the rules of quantum physics are much more different than the rules of neural networks. And the thing about it is, when you look at the brain and you see how it works, there are these things in there, these little proteins called tubulins. And the tubulins can actually trap an electron in an up or down spin state at the same time. Ooh, just like Schrodinger's cat. Well, that suggests that what we have is a system that is a quantum computer. So your brain is a quantum computer. If that's the case, then every thought that you have is working through the laws of quantum physics. And it turns out the way quantum physics works is you can take events that are coupled with each other. An event that happens here, an event that happens there, whatever. If they were somehow ever quantum coupled, they interact with each other instantaneously across the universe no matter what distance. Einstein hated this, but we've recently proved that that's the case. So think about that. If you have a thought, your brain is setting up some quantum wave function that is interacting with the entire universe all at once. That's kind of heavy if you ask me. And so here's how it works. Quantum computers don't work like regular computers. Regular computers do a dictionary search to find the answer to a problem. Okay, they go through all the possibilities to give you the answer. Quantum computer doesn't. A quantum computer says, what's the question? So in this case, your eyes see something. And it sets up, here's what I see in a wave function. And then it compares that quantum wave function to all the other quantum wave functions in the database, your brain. And instantaneously in quantum physics, like things stay, unlike things go away. So boom, all the things that are not what you just saw disappeared, and the thing that is appears in your mind, and you realize, oh, I just saw a pretty cool race car. And so that's how a quantum computer works. And that's how our brains work. And I'll show you that right now. Who sees a triangle? And who sees a square or a rectangle? Man, I drew a perfect square. Anybody see it? Anybody see it? No, you don't. It's not there. There's a bunch of red Pac-Man. What happened? And you saw it instantaneously when you saw it, didn't you? Yeah, you did, because your brain just did a quantum reduction. We call it orchestrated objective reduction. And what just happened is your brain said, boom, this is what's in my eyes, okay? I've got to compare it to all my database. And it goes and instantaneously compared to everything in your database using the laws of quantum physics. And what came out of it was a triangle in red Pac-Man and a rectangle in red Pac-Man. Well, because that's what it closely correlated to. It's not exact, because quantum physics is you compare this ripple with that ripple, and the ripples that are closest together is what you see or experience as reality. This is a simple test to show that your brain doesn't use neural networks. And so what we are is we're floating around in this quantum sea of the universe, where everything in the universe is once was this little bitty teeny tiny quantum wave functions. Now it's a big one from the inside out anyway. And we're connected to it with everything we do, with every thought we have. Everything we think is going out there into the universe. That's crazy, man. That's crazy. All right? Well, so control your thoughts. That's what it's telling you. Control your thoughts. Because what you're thinking is interacting with the entire universe.
Every time we put a limitation on Mother Nature, she defies our box. She defies the parameters for which we set. Every time we say every living thing needs water or oxygen, we realize that there are microbial life out there that are anaerobic. In fact, they'll die if you put oxygen. They like a non-oxygenated environment, right? You have these extremophiles living at the bottom of the ocean and miles below the Arctic ice. This defies any definition of life. In fact, a virus itself, in one case, you can make the I think you can make the claim that it is a living organism because it replicates and it does a lot of things that a living organism does. But it also can be defined as a non-living thing because it doesn't have DNA and it doesn't have a lot of the things that we clearly associate with a living organism, like respiratory functions, right? Like anabolic activity. So I think we need to be very cautious how we define life.
If the general public knew or saw what you saw, what would the next week look like? How would the public react?
Somber. I think there would be this big exhale for about a day. And then this turning inward and trying to reflect on what this means to us and our species and ourselves. I think
somber. Sorry, like a sigh of relief.
Somber meaning serious, not like Hollywood portrays people partying in the streets and silliness like that. I think you would have some people perhaps turning to religion more so. You might have some people turning away from religion. I think you're going to have, at that point, the philosophical and theological questions will be raised, and people will have some serious soul searching to do, no pun intended.
Alexander argues that all of these seemingly unrelated weird subjects might share a common link: consciousness.
I think one of the mistakes that are made in these fields is they tend to stovepipe. They delineate. I'm going to talk about UFOs, near-death experiences, psychokinesis, ghosts, whatever it is, and look at them in separation. And I think what we need to do is step back and look at them in totality.
Bigelow has been funding UFO research for more than 30 years and has likely spent more on that mystery than any person in history, including his purchase of a paranormal hotspot in Utah known as Skinwalker Ranch.
Yeah, you have this dichotomy between the brain and mind, right? The brain is the physical manifestation, and the parochial thinking is that when the brain ceases to function, you don't have a mind.
That's it.
There is no consciousness. And so we know by a number of different ways that the brain can cease functioning but your mind can continue. Well, then where the hell is your mind? You've lost your mind, right? So where is it?